So this is about inner classes and Lambda expressions. Inner classes have been around with Java for a very long time, since I guess 1.1. And Lambda expressions, I think, came in with Java 8. So they're relatively new. Generally speaking, Lambda expressions can be used where inner classes are used, and inner classes can be used where classes can be used. So it's all designed to make things a little bit simpler. So I'm going to make a class here. And I'm going to make another class, bar. And bar is going to make use of foo, or foo is going to make you. Here, I'll do this. I don't like this example so much, but it does actually make it a little clearer to you. So egg is the outside and yolk is the inside. Think about a chicken egg, right? It's got the hard shell on the outside and the yolk on the inside, along with the other stuff. So all eggs have yolks. And let's say that there's a private variable, which is the weight of the yolk. And we'll also say that the weight never weight never changes. So when we create an egg, we need to make that yolk. And we'll go for override toString. Sure. Just seeing what our default toString looks like. So now I'm going to come in here and I'm going to make a so this egg has a yolk that weighs 10. So you may not know this. When you do system.println, you'll see that there's a whole bunch of different overridden methods, but only one for object. What object winds up doing is just calling toString, which is why we want to override. When we override toString, it does what we want, which is make that object print. So that's just a little bit of trivia for you. So this should print out that it's got an egg with 10, or with a yolk that's 10. Right, there we go. So all well and good, everything works out great. The only issue I have with it is that it doesn't really make sense to have a yolk that's not part of an egg. You can put this class anywhere inside of the other thing, the other class. It doesn't matter. This is called a nested class or an inner class. We want to make them static. I can explain that in a little bit. And we can go ahead and make it private. So the one cool thing is, this allows us to organize our code a little better, right? So we've got packages, we've got classes. Now we can have classes that are inside of other classes. Because the yoke is an integral part of the egg, just like the methods, we have special access. So even though this is private and this is private here, we can just get access to the weight directly. And it's no problem. I run this code, it'll be exactly the same. The rationale for that is that, just like I said, this class now is part of the implementation of this class. And you can't imagine inside of a class not being able to call one of your methods or access one of your variables. So the same logic applies here. And if we had a variable here, we didn't make this static, and I'll explain that in a second. We can say x is assigned 55, and we can access that x variable, right? There's no compiler warnings or anything. It's all happy. So even though this is private here, doesn't matter. So just like you can't imagine a variable or a method inside of your class that can't access one of your variables, the same holds true here. You can't imagine a inner class not being able to access the members of the parent class, and you can't imagine the parent class not being able to access the members of the inner class. They are totally intertwined together, right? So eggs don't make sense without yolks, and yolks don't make sense without eggs. So it's just a nice way to organize your classes so that you can remove you can make these dependencies inside the class. And we see this, and we'll see it later on in the course with like a linked list. Every linked list has what we call a node in it. The node would be a private class. So if I make this static, though, it doesn't work. Why doesn't it work? Okay, so think about what static means. And it means many things in different contexts, but in the general context, it means that we can be using this without an instance. Okay, so we don't need an instance of the egg class. Another way to look at it is this is shared amongst all the eggs, but it's not. Every egg can make a new yolk, right? So what happens is that secretly, and I'm not going to go through all the details, but there's the compiler adds in this kind of thing here, right? When you're static, that doesn't get added. When you're not static, it does. And then the compiler basically says that this is called outer.x. Don't worry about all this right now, the details of all this. But basically that outer that I just deleted is pointing to the egg that was created. So it's actually pointing to this new egg. So this means that every yolk you create knows about what egg it belongs to. When you make it static, it's just a yolk and it doesn't know what egg it's inside of. We prefer to make things static if we can. If we make them static, it also helps with the organization a little bit in that, as you can see, we can't access things inside of the egg. The egg can still access stuff and variables inside of us. 9 times out of 10, you want to make things static. Right? But probably you'll find books, websites, and students and new programmers and all sorts of things just are, for lack of a good term, lazy, and they wind up doing this when they don't need to. So try to make your classes static. If you find out that the inner class needs to access the outer class, then make it not static anymore. Okay? But just by default, you should make everything private. By default, you should make all of your nested classes static. And again, there's no need for me not to have that as static, so we're going to keep it static. It goes even further. I can't show it with this code, so I'll make some new code. Right? So I can make a class inside of a method. I can make a inner class inside of an if statement. I can make an inner class wherever it makes sense to me. I would use this with caution, right? This is not a thing I would actually do. Actually, that's not true. I have done this once before. I would be very careful about doing this. You'd have to have a really good reason to put it inside of like an if statement or a method. If you do it, there's nothing wrong with it, but it's really odd. Like I said, I've done it once since JDK 1.1 came out, so we're talking like 97, 90, 96, 97, 98, somewhere in there. Once in a long time. Over 20 years. So it's not common. But you can do it, right? So that's awesome. Just the idea that you can put them anywhere. It's nice and consistent. I like that. So here's why you wouldn't put a class inside of a method. This class here is only visible within the main method, right? So we can't actually pass it out over here. To make it visible, we have to at least move it outside of the method. That's visible in here. So now I can make a final x. X is assigned new x 10. Oh. Also, if it's not static, we're trying to access it from a static method, so it has to be static. And I also want this to be static, not for that reason, just because I want to call it directly from main. If I didn't have this as static and I tried to call foo passing an x, it's not going to compile because foo isn't static. Okay. So this should work, and it should print out 10, right? Oh, that'll run the old one. Right, so it printed out 10. If I change this to 20, it should now print out 20. Right, just regular polymorphism kind of stuff, right? We're going to pass x to foo. Is x of type x? It is. Does x have a y variable? It does. So it prints it out. Here's where things get funky. I'm going to make your life even more confusing for a second first, though. So interfaces don't have to be static, they're static by default. Oh, that's A. So now I have my interface A, it has a getY method, and here I've got my class X that implements A. So now I can have this take an A, right? And I can't call Y directly anymore because well, we're passing an X. This code here doesn't know what we're passing it. All we know is we're passing it an A, and A has a getY method, so I have to call that. Okay, sorry, it doesn't all fit in one screen. I will be posting the code as well. So, right, there's nothing strange going on here. You've seen this hundreds of times now. The only difference is that I've moved these things inside of the class. I could move them outside of the class. And run it. And it works fine. I can move them back inside the class. So there's no difference. We've seen this many times before. Run it, should print out 20 as well. Right? So this is not new. The only new piece is that we've moved these inside of the class. Everything else is going on exactly the same. This is where things get odd. Now, you're probably confused at the moment. I mean, the code's not compiling, and you're probably, well, that makes perfect sense that this code doesn't compile, because what am I doing? Pause for a second, see if you can figure out what the problem is. Okay, so the problem, from your perspective, might be we're trying to say new on an interface. And I've told you, and all the instructors before have told you, you can't say new on an interface. But I'm going to tell you that I can. See, code compiles. If I run this, the code's going to print out 42. Witchcraft. It's close to Halloween. So this doesn't make sense though, because I'm saying new on an interface, and I can't. Just the other week I told you can't say new on an interface. So either I'm lying, or I don't know what I'm talking about, or the actual thing, this is not doing what it looks like it's doing. We're not making an instance of an A. You'll notice these curly braces. We're doing essentially, and you can't do this won't compile. What we're doing is this. So we're essentially making a new class that implements A, and somehow then saying new. Sorry, I guess I make that syntax a little better. The syntax is odd because it doesn't exist, right? It doesn't compile. So we're making a class, we'll call it $0, that implements A, and then we're making an instance of that class. And I can fix this by doing this. I know this is going a little fast, and I will show you the two differences between them. Okay, so let's look at this one first. Do we agree, based on everything that we've said so far today, that you can do this? Can we make a class inside of a method? Yes, we can. Can we make an instance of that class? Absolutely, it's just a class. So that's fine. That is literally what this thing does here. The compiler basically takes this code that you wrote here and converts it to this code here. Right? So it's exactly the same thing. So this should print, and I'll make this one return 52. So when we run this, this should print out 52, and this here should print out 42. Right? So it's not a good idea to ever name your class with a $sign. That's what the compiler does when it does this little trick. And this is what we call syntactic sugar. So these two things are exactly the same thing, but this is less work, right? It's easier to type this. But I'm going to tell you we can take it one step further. And I'm going to introduce this concept here, and we'll talk about it in later classes. So we can get rid of this whole thing, and we can replace it with what we call a Lambda expression. So a Lambda expression works with methods that have, or interfaces that have one method, essentially the command pattern. Right? So we can say we're going to write a method that takes no arguments, and the code is going to return 42. I'll make it 62 this time. And let's run that. There we go. It worked. So this thing is literally the same thing we wrote before, but with way less work, right? So we're overriding a function, a method that takes no arguments. Awesome. And it returns an int. It gets even stranger, actually. I think this will work. Yep. So there, now we're returning 72. So I'll explain it in a second, but there we go, 72. So what we have here with this arrow syntax is we have the parameters we pass in over here, and we have the code for that method. If it's simply going to return, we can just have the value. If we want to do something else, something like that, then we can write return, or we're going to write if statements or whatever, right? So we should be able to write here if argv.length equals 0, return 1, otherwise we'll return 2. And this should return 1 because we're not passing any arguments. If we passed in arguments, it would return 2. So we can make this as complex as we want, but generally speaking, we keep it really simple. Okay. And if said this took a value, get rid of this inner class here. So this now, if we just say return 3, sorry, 3 like we did before, this doesn't work because this function here now takes a value, right? So int val. And now it works, and we can actually say 3 times val. So this should now print out 6 because we're returning 3 times the value passed in. The value passed in, and the value passed in here is 2. And we actually don't even have to say int. It infers it. This is very different syntax. This is a big departure from the way Java typically works, and it also causes all sorts of problems with exception handling. For example, if this thing needs to throw an exception, we wind up being very problematic. So depending on what you're going to do, inner classes are actually a nicer fit for it. Oh, sorry, I did forget to mention the one before this, the one where we just said foo new a and did the whatever work in there. That's called an anonymous inner class. It's anonymous because we're not giving it a name. Right? So we're going to actually make heavy use of the Lambda expressions. So you're going to see the syntax. I'll go, when we do collections, I'll do Lambda expressions, but I'll also use the inner classes again, just so we can see them both. So consider this to be a precursor of some things that are coming. But it's, inner classes are used quite a lot in GUIs, although GUIs tend to or seem to be on their way out in terms of Java, but they're used a lot in graphical user interfaces, GUIs, and Lambda expressions are used quite a lot in collections. Inner classes used to be used in collections, but they should probably all be replaced with Lambda expressions now. So we're going to see these in the context of collections shortly. And I think that's a good place to stop for tonight, or today, or whatever you're watching this. So I'll just recap. Right? We have classes, right? Top level classes. Those are classes that exist at the top level of a file, hence top level. We have nested classes. That's classes inside of other classes. Oh, and just to be clear, this could also be out here. It doesn't have to be inside the class for any of this Lambda stuff to work. So we have classes that nested classes. Those are classes inside of other classes. We have the, and they can be inside of if statements, methods, for loops, whatever you want. Basically, if it has curly braces, you can put a class inside of it. You can even make it look like you're putting a class inside of a method call by saying that new A and all that. That's an anonymous inner class. And then we've got here lambdas, which is by far the simplest version. The reason people like inner classes and lambda expressions is that it makes the code for things much closer to where you would see it, or where it's used. So people tend to think that it makes the code easier to understand. I don't agree with that in many cases, but actually in the case of collections, which we'll see coming up, I think it does a really good job in simplifying the collections. You can do a lot of really powerful things with them. So awesome. All right, I will talk to you in class.